This video is for the Unit 2 questions on your Honors Algebra 2 exam review. That is on Unit 2 is for functions. Okay, so we're going to start here with choosing from these graphs all of those that represent a function. Remember, to decide if a graph represents a function, you need to decide if it passes the vertical line test. Okay, the vertical line test means that if you drew a vertical line through each graph, that the vertical line would only pass through the graph one time. It looks like A is going to be a function. B also seems like it represents a function. I would say C as well. It's hard to tell here, but remember that word asymptote? If I drew a vertical line down the y-axis here, both parts of that graph approach the y-axis but do not actually touch it. So that's going to be a function. D fails the vertical line test because when you draw a vertical line, it crosses the graph multiple times. E is also a function. F fails the vertical line test. G is a function. And H is not a function. Look right here. If I drew a vertical line through those 2 points, it would cross through 2 different points there, so that would not be a function. So you should have A, B, C, E, and G circled. Now part B says, of the functions you circled, which letter, or write the letters of those that are also 1 to 1. Now 1 to 1 means you pass the vertical line test, so you are a function, and you also pass that horizontal line test. So the graphs that pass the horizontal line test would be A here. B does not pass the horizontal line test. C does. We have an asymptote at the x-axis as well, so that would pass the horizontal line test there. E would fail, and so would G. So A and C are the only functions up above that are 1 to 1. All right, number 2, which of these ordered pairs are not a function? Now, in order to look at this, you need to remember the definition of a function that says that there is one y value for every x value. Now, one way we looked at that when we had sets of ordered pairs was we said that no x value, that's at least your hint to get started, no x value should repeat. So again, that's the first thing you just look for, and then we can decide from there. So we want not a function. So if I'm looking for ones that are not a function, I want to see which x values do repeat. Which actually it looks like this first one might be our not a function here. I have the x value of 2. It shows up twice, and there are 2 different y values for that x value. So that means that A is not a function. If I look at every other set of ordered pairs here, every x value is different, which means that those all represent functions. All right, number 3 uses the functions G, H, and F all over here in the box and the graph. You're going to use those to answer these questions. A says we need to find G of 5 times F of negative 2. So I'm going to write it out the long way. You can do it faster if you need to, but I'm going to show all the steps just in case anyone needs to see it. G of 5, you're going to start with this function of G over here in the box, and you need to find the value of G of 5. G of 5 would be 12 times 5 minus 3. 12 times 5 is 60. 60 minus 3 is 57. So I'm going to take that 57 along with the fact that f of negative 2 from the graph over here, if I go to x is negative 2 and go up on my graph, I get an output of 4. So I'm going to use that 57 and 4 here to find G of 5 times f of negative 2. And I multiply those together to get 228. 228 would be your final answer. In B, it's a similar kind of problem. I'm going to start with H. H of negative 3. Put a line here. I'm going to use this function over here. Make sure when you square a negative, you put it in parentheses. Negative 3 squared plus 2. That's 9 plus 2, which is 11. And then I need to find g of negative 1 before I can move on here. So g of negative 1 is 12 times negative 1 minus 3. Negative 12 minus 3 is negative 15. So to simplify that problem, I'm going to go up above here. I'm going to take h of negative 3, which was 11, plus 2 times g of negative 1, negative 15 here. So that's 11 minus 30, which is negative 19. That would be your final answer for B. So you need to understand function notation for those problems, as well as understanding how to read the notation that is written, the multiplication, the addition, that kind of thing. Now, part C says find x when g of x equals 51. Remember that when it says equals 51, that 51 is an output, or y value. So you're going to set that 51 equal to the function of g of x, 12x minus 3. And all you have to do here is solve for x. I'm going to add 3 to both sides, which gives me 54 equals 12x. And I'm going to divide by 12. 54 divided by 12 is 4.5. So 4.5 is the input, or the x value, for the function of g that gives us an output, or an answer, of 51. All right, now we get to some composition of functions, h of f of negative 4. When I'm doing composition, this operation tells us that you need to do the function on the right first. So we need to first find a value for f of negative 4. So you're going to go back to your graph. F of negative 4 means you go to where x is negative 4 right here, and you find the output for the function, which is 2. You're going to take that 2 and put it into the function on the left, which is h. So you now need to evaluate h of 2, which would be 2 squared plus 2. 2 squared is 4, and 4 plus 2 is 6. So that is the value of h of f of negative 4. All right, last one of this row here, E. G of h of negative 4. So this time I'm starting with h of negative 4 because that function is on the right. So I'll put negative 4 in parentheses here. Negative 4 squared plus 2. That gives me 16 plus 2, which is 18. That 18 goes into the function on the left, our g. So you need to find the value of g of 18. G of 18 would be 12 times 18 minus 3. 12 times 18 is 216 minus 3 is 213. All right, we are almost done here. We have, try to make sure I can see the functions, some more composition here. F is similar to the 2 we just did. G of h of 0. You start on the right with h of 0. All right, h of 0 would be 0 squared plus 2, which is just an output of 2. I'm going to take that 2 and put it into the function on the left, which is g. G of 2 is 12 times 2 minus 3. So 24 minus 3, which is 21. So for those last few problems, and actually A through F, every single one of those problems, your input was a number. So your output, your answer, was a number. Now for G and H, your input is a variable. It's a function. Here on the right, we have G of H of X. So my input is H of X, which has an X in it. So my answer has to have an X. So here, you're going to take the function of H and put it into the function of G. So up here, I'm taking this X plus 2 and putting it into x for g. So you would have 12 times x squared plus 2. And then don't forget to put that minus 3 on the end. To simplify this, you're going to distribute the 12 to both terms, which would be 12x squared plus 24 minus your 3. You can combine these like terms here, and your final answer is 12x squared plus 21. That is the new function you've created called g of h of x. Finally, in h, you're finding h of g of x, so the other way around this time. This time you're putting g into the function of h. So what that looks like up here is you're going to take this 12x minus 3 and put it into x inside of h. So I'll write it first so we can see the functions, then I'll move the screen on. So the g here, instead of x, we're going to put 12x minus 3. We're going to square it, and then add 2 onto the end. Now, the tricky part about this problem is you need to remember, when you have a quantity squared, you need to rewrite that as 12x minus 3 times 12x minus 3. You are not allowed to just jump right to 144x squared minus 9. You are going to need to distribute here. So you're going to take 12x times 12x, which is 144x squared. 12x times negative 3 is minus 36x. I get another minus 36x here. And negative 3 times negative 3 is plus 9, plus the 2 that came down from the end. And all you have to do now is combine like terms. The 144x squared does not change. This becomes negative 72x. And at the end we have plus 11. That is your new function, h of g of x. Okay, lots of composition there. When I move on to number 4, we are given the functions f and g below. We are going to do two compositions here. We're going to find f of g of x and g of f of x, and then see if we can make a decision, if we can recall what the answers tell us about these two functions. So I'm going to start here with f of g of x. Now in this problem, we're starting with g on the right, which means you need to take g and put it in for x and f. So you're going to have 3, now in your parentheses, x minus 7 over 3, plus 7. Now here, the fast way to do it is that these 3's can cancel off, right? One's kind of in the numerator of a fraction, one's in the denominator that you're multiplying together, so you can just cancel those 3's off. If you wanted to, you could distribute the 3 to the numerator and then simplify the fraction. But I'm going to do this way because this one's faster. You're left with x minus 7 plus 7 now. Well, those 7's add to 0, which means your result is x. That's the value of f of g of x. Let's do the other composition, g of f of x. This time, f is on the right, so you're going to put f into the function of g. So instead of x, you'll have 3x plus 7 minus 7 all over 3. Now be careful with your order of operations here. You can only start by adding those 7's together to give you 0. Then you have 3x over 3. You cannot cross the 3's off from the beginning because of the plus and minus signs in the numerator. Those prevent you from canceling it. Now that the plus signs are gone, the 3's do cancel, and you get another result of x. Now, here's what you have to remember. It says, what does this tell you about the composition? Well, if I do two compositions, they both give me the result of x. That means that f and g are inverses of each other. Okay? So you just found, or verified, did a math proof, if you want to call it that the two functions f and g are inverses. All right, we have a little bit more here with this functions unit. It was quite long. Next, we're going to do domain. We're going to find the domain of each function. It says in A and B, the first two, we're going to write set notation and interval notation. And then for C and D, we're only going to use set notation. So for A, I have a value under a square root, an equation with a square root. Remember, square roots. I know that we've recently learned I, but in general, that's an imaginary number. You can only have positives and 0 underneath your square root as your radicand. So to find the domain here, you take the radicand and you have to set it greater than or equal to 0. Then you solve this for x. You subtract 2 from both sides. And then, subtract 7. Then you divide by 2. Now what that gives you is, I'll do set notation first. Set notation is the one with the curly brackets. We want all the x's such that these x's are greater than or equal to -7 over 2. If you want any number bigger than -3.5, -3.5 or bigger is okay to go in for x there. Now we need to also write this in interval notation. So sometimes it's easier to think about a number line picture here to make your interval. All right, here's 0, and -7 over 2 is down here. That's your -3.5. Because there's a line greater than or equal to, we put a closed dot on that number line, and all the numbers that are greater than that value are to the right. So if you wrote your interval, you would have a square bracket at -7 over 2, and since the arrow is going to the right forever, it's going towards infinity, and infinity always gets a parenthesis. Okay, that's the two ways to write the domain for letter A. For B, we start the same way. We have a square root, so you take what's underneath the square root here, 5 minus x, and set it greater than or equal to 0. All right, now subtract 5 from both sides, and you get -x is greater than or equal to -5. But remember, if you have to divide by a negative when you simplify or solve a inequality here, the inequality symbol is going to flip. So our domain is that we want all the x's less than or equal to +5. -5 divided by -1 is +5. So if you make your number line here so that you can do your interval notation, we put a value at 5, a spot at 5, and that's going to be a closed dot again. But this time we want all the x's less than that, so to the left here. If I match that to an interval, on the left my arrow is going towards -infinity. It's going that way forever. And my number line only goes up to 5 with a closed dot, so it gets a square bracket. Now A and B are different than C and D. C and D have a fraction. And remember, fractions, you are not allowed to have the number 0 in the denominator. That makes the fraction undefined. So to find the domain here, you're going to take your denominator and set it not equal to 0. Now you're going to solve for x. So I would subtract 4 from both sides and get -2x is not equal to -4. And then divide by -2. Right? This one, we only are going to use set notation. You want the x's such that x is not allowed to be equal to the value of 2. That is the one number. X can be anything else except 2. And I'll show you why. If I put 2 back into the denominator right here, I'd have 1 over -2 times 2 plus 4, which gives me 1 over 0, which is bad. We cannot have 1 over 0. That's not happening in the math world. D is very similar. We have the denominator of x squared plus 7x plus 10. That denominator is not allowed to be equal to 0. Now, we've recently done this in our solving quadratics unit. To solve this quadratic here, you have to use the zero product law, which means you have to factor. This is a trinomial with leading coefficient of 1, so I can go ahead and jump to factored form. I need two terms that multiply to 10 and add to 7, which are going to be +5 and +2. So I have x plus 5, x plus 2 is my factor form not equal to 0. And then you have to set each one of these factors individually not equal to 0. When you solve those, you would get that x cannot be negative 5 or x cannot be negative 2. Or either one. You can't have one of those or the other one. So when you write your set notation here, you want to say you can have any x such that x cannot be equal to negative 5 or it cannot be equal to negative 2. Either one of those x values would give you a denominator that's equal to 0. So that's a little bit of review how to find domain from an equation, our special domains. Now we're just going to do domain and range from a graph. We're going to write those domains in interval notation. All right, number 6a here. My domain, remember domain is the x's, range is the y's. So when I look at my domain, I start on the left. The leftmost value here is at 1. There's an endpoint, so I put a square bracket. The rightmost value here on my graph is at 5. It also has an endpoint, so it gets a square bracket. The range is bottom to top. So the lowest y value is at 0. The highest y value is at 6. So that would be your range in that problem. In B, domain goes left to right again. And notice on the left and the right, you have arrows going out forever. So your domain on the left, or the domain here, goes from negative infinity to positive infinity. Whereas your range works bottom to top. So on the bottom, we're starting at negative infinity, and we only go up to 4. There is a value at 4, so you put a square bracket. On C, our leftmost x value is at negative 1. The rightmost x value is at 5. So you put square brackets on both of those. The range bottom to top goes from negative 3 here all the way up to positive 3. And there's a little bit of review of domain and range from a graph. All right, a couple more problems in this functions unit. Number 7, all of these questions refer to the graph that's on the screen here. First, we're just starting with function notation, f of negative 4. Remember, any number that is in the parentheses is an x value. So if I go to where x is negative 4 on my graph and go up, it looks like the output is at 5. I do the same thing here with f of 0. The input is 0. The output also, again, is 5. This time for an input of 5, I go all the way up, and my output is at 12. Now there's a different question next time in D. It says, what is x when f of x equals 0? Now when it says f of x equals 0, that 0 is a y value. So you're going to look, where is the y value 0? Well, that seems to happen right here at that x of negative 5. Similar question here in E. What is x when f of x is 8? So when y is 8 here, look at how many x values there are that give you that same output. Looks like that's at the x of negative 3, negative 1. This one's at 3 and 7. So there are 4 x values that give you the y value of 8. All right, next it asks you for the absolute maximum. Remember that absolute maximum means the very highest point on the graph, which would be this point right here. That looks like it's at 5/12. Now the absolute minimum would be the very lowest point on the graph. But notice here on the left, this part of the graph has an arrow that goes down forever. Because the graph never stops going down, there is no absolute minimum because it never stops going down. The next question asks you for relative minimums. Now the difference between an absolute and a relative is that absolute is the very highest and the very lowest. relative minimums can occur within the graph, and these are going to be your valleys of the graph, right? So it looks like on our graph here, we only have one valley, this part of the graph right here, and that valley occurs at 1/4. Right? That is going to be a relative minimum. For a relative maximum, you want the mountaintops or the peaks. And it looks like I have 2 peaks on this graph. One of them is at -2.9, and the other is our absolute max of 5.12. Yes, an absolute max can be a relative maximum as well if it's a mountaintop. All right, the y-intercept, that should be an easy one for you. Where do you cross the y-axis? Here that is at 0.5. The x-intercept is where you cross the x-axis. That's at -5, 0. Domain and range, we just reviewed on the last problem. Domain are your x values from left to right. On the left here, I have an arrow, which means my graph goes to the left forever towards -infinity. And I only come up to this x value over here of 8. Now there's an open dot at 8, so you're going to put a parenthesis. There is no actual value there at x of 8. The range is bottom to top. Again, we have an arrow going down forever, which means my range goes from -infinity, and the highest y value comes up to 12. There is a value at 12, so you close the bracket there. Finally, we're looking at intervals of increase and decrease. Interval of decrease is where the whole interval where your graph is going up. So looks like I'm going up here, and I'm going up here. Now the intervals of increase, you can write in either as an inequality or as an interval, in interval notation. You use the x value, so you read the graph from left to right here. For this first yellow interval, there's an arrow on the left, which means you're increasing from -infinity until you get to the x value here of -2. All right, we're going to use parentheses there because we're not actually increasing at -2, just up into that value. Then we have another interval, so we have to put our union. We are now increasing between these next 2 green lines at 1 and 5. So you can write your intervals of increase that way. Decrease here, I'll use a different color. You're decreasing on these blue sections. So we're going to look between the x values here of -2 and 1. We again use parentheses. And we have another interval, so we union that from 5 to 8. You are also decreasing between those 2 x values. Let me know if you have other questions on that problem. Like the intervals and the relative maximums, that's kind of the challenging part there. All right, 8 and 9 are going to deal with inverses, and then we will be done with our functions unit. For inverses, remember you have to switch the x and the y value. So you just flip-flop the letters here. X equals y plus 2 over 7, and you just solve for y. That's how you find the inverse. So we'll start by multiplying both sides by 7 and get 7x equals y plus 2 and subtract 2 from both sides. That tells me that the inverse function of y is 7x minus 2. B, I'm going to do the same thing to start. I switched the letters x and y. Now f of x here is the same thing as y. So when I switch those, I get x equals 3 over 4y plus 1. I start by subtracting 1 from both sides, and I'll get x minus 1 is 3 over 4y. Now I like to clear the denominator first, so I'm going to multiply every term by 4. That'll give me 4x minus 4 equals 3y, and then you can divide by 3. Right? You can divide every term by 3, or you can just divide the whole left-hand side. It doesn't really matter. I'm going to do it this way. So my answer is 4x over 3 minus 4 over 3 equals the inverse. Or you could have written that 4x minus 4 all over 3. Either one, they're exactly the same. It does not matter as long as you can read the difference between the two if it were a multiple choice question. All right, C. Remember, g of x is the same as y. So you have y equals 5x minus 3. You switch the x and the y values. So you'll have x equals 5y minus 3. And you're going to solve for y. You'll start by adding 3 to both sides. And get x plus 3 equals 5y. And divide everything by 5. Now, just like the last problem, you're welcome to leave this inverse as x plus 3 over 5. Right? That's totally okay. Or you could rewrite that as x over 5 plus 3 over 5 equals y. That is exactly the same thing, and that is a fair answer as well. All right, last question here of the functions unit. We are going to do inverse again, but this time we're going to graph it. So we're going to start with the graph 2x minus 6. Okay, so we need to graph that on this grid. Now when we graph that, we should notice that the y-intercept here is at negative 6, so that's where I start. And I have a slope of 2, which means from that point I'm going to go up 2, right 1. Take a second here and plot your points. If you can't go this fast, just pause the video. And then you'll connect your dots. Right, that's our graph of f of x. That is the function that we are starting with here. Now we need to find the inverse of this graph, which just like above, means you need to switch the x and the y values. So I'm going to start by writing this as x equals 2y minus 6. To solve this for y, I'm going to add 6 to both sides. Now then x plus 6 equals 2y. And then you need to divide every term by 2. Make sure you write it this way this time, because when we graph, we need to have a fraction for our slope. That solved is x over 2 plus 3 equals y. That is the inverse function. So when I graph this, I start at my y-intercept of 3, and notice that my slope is up 1 over 2. It's 1/2. So you're going to plot all those points on your grid so that you can get a really nice line here. Again, pause the video if it takes you a little bit longer to plot those points. That's the graph of the inverse, f inverse of x. The last question here says, what line do inverses always reflect over? This is really important. We talked about this in this functions unit and the logarithms unit. Inverses reflect over the line y equals x, which is the line with a slope of 1 that goes through the origin, that green line right here. You should notice that your two graphs, f and f inverse, reflect over that green line. All right, if you have questions on the functions unit, let me know. Come in for a little bit of help. Otherwise, if you need help on any other units, the videos are on campus.